Welcome back to Math on the Fritz with Mr. Fitz. If you look at the three examples here, you'll notice that all of them have exponents, which are fractions. And in particular, if you look at this first one here, x to the 3/5 equals 27, you'll notice that the only thing preventing x from being alone is this 3/5 power. So I'm going to start with this particular problem by raising a power to another power, because that's the most efficient way that I can deal with that 3/5. Now, because I want it to be 1, all I'm going to do is flip this. I'm going to use the reciprocal power. Now, it doesn't look like the greatest fraction in the world, but 3/5 times 5/3, power to a power rule, you multiply exponents, I should end up with 1 if I multiply those together. 15 divided by 15 is 1. So effectively, by doing that trick of flipping the fraction, I was able to make my left side x. Now the right side, I still need to figure out what is 27 raised to the 5/3 power. Well, if I rewrite that in a better way, I can take this 3 that was the denominator and say it's a cube root. So what I'm really looking at now is the cube root of 27, and then I'm going to raise that answer to the 5th power. Now the good news for us is we're trying to pull out triples, but our number is a triple. 27 is 3 times 9, 9 is 3 times 3, so 27 is really 3 times 3 times 3. If you wanted to see it in the tree, we could do it. 3 times 9, which is 3 times 3. I now have a triple. I have a 3 of a kind. So my answer for the cube root of 27, as you can see from here, is 3. So I end up with the answer 3 to the 5th power, which, if we had a calculator, would be a little easier. I'm thinking it's 243, just from memory. I could check it on my handy-dandy TI calculator. 3 to the 5th power, 243. So x equals 243. So that's the same basic idea that we're going to carry with us through every problem. Whatever my exponent was, I know that I'm going to have to flip it, because power to a power you multiply, and I'm trying to get an answer of 1. That's why I'm flipping it. Now over here I have a similar type of problem. X is by itself on this side with the negative 2/3 power, but you'll see there's a negative there. So when we choose what to use, I need to get x to the positive 1 power. So when I flip it, I am going to have a negative exponent here. I'm going to have to do that. I'm going to have to raise this to the negative 3/2 power so that I can get negative times negative is positive 6 divided by 6, which is 1. But that means raising this to a negative power as well. So my left side is x, which is what I wanted. But my right side is a little harder to make sense of. That negative exponent is telling me that I really want to flip this. 1 over 64 should really be 64 over 1. Now, whether I want to do that right away or if I want to save that for the end is really your call. If I do it right away, then what I end up with is 64 to the 3/2 power. Now everything's positive and I can think of it in a little nicer way. I don't have to do 64 over 1 because I already know what that is. Dividing by 1 doesn't change anything. So I'm just going to rewrite this with a positive exponent. Still a fractional exponent. I haven't done anything with this 2 down here. I was just trying to resolve what does that negative mean when it's an exponent. It means that I have to get the reciprocal of that fraction, flip this one. Now I can write it as a positive. Now I'm going to do the same thing I did over here. This 2 on the bottom really means square root. So now I'm looking for pairs that I can pull out of 64. And then whatever I get for an answer, I still have to raise it to the third power. So I'm ready to find pairs of 64. 8 times 8 is 64. And look, that's a pair. So I was looking for pairs. It's a square root. I found a pair. 64 is a pair of 8s. So this turns into 8. Now I want to remember that it's still being raised to the third power. Now I'd probably want my calculator for sure. 8 times 8 is 64, but then 64 times 8, 512. All right. So 512, it's kind of a big number, but we're not worried. We're going to get big numbers and things mixed in here. So first example, I flipped the fraction, did it on both sides, ended up with an answer, made me happy. This time I did the same thing. I flipped it, but I had a negative exponent, so I had to address that negative exponent. I flipped this and made it positive so that I could deal with it a little easier. And then we have our last thing. The last one you're going to notice is not ready to be flipped yet. On all the other examples that we did, you had the x by itself already. Here we don't have that. We have two terms on this side of the equation. And I don't want two terms. I want a single monomial term sitting over here when I'm going to solve. So let's get rid of this 30 first before I try to figure out what x is. If I get rid of the 30 with a minus 30, now I end up with 16 on this side, which is a single number. But on this side, I only have a single thing, which is 4x to the 2/3 power. Now we can do the same trick that we did when we were over here. Even though it's a group of things inside, it's still labeled as a group because of the parentheses. So I'm happy now saying, let's take this whole thing to the 3/2 power. Let's take this thing to the 3/2 power. Again, as long as I do it to both sides of my equation, I'm fine. And I've done it to both sides of my equation. Now, when these cancel out and give me 1, I still have the 4x there. I didn't lose the 4x. I've still got that stuck. But on this side, I have 16 to the 3/2 power. Again, the number on the bottom just tells me what the root is. It's a square root. Because it's a square root, I'm looking for pairs. Once I get my answer, I have to raise that to the 3rd power. Square root of 16, I'm looking for a pair, which is 4 times 4. That is a pair, so I can stop there. This is going to turn into 4 to the 3rd power equals 4x. Now, I happen to know 4 to the 3rd power is 64. 4 times 4 is 16. 16 times 4 is 64. So I'm going to write 64 equals 4x, and then I can solve my equation. All I have to do is divide by 4, and my problem's done. So it involved a little more thinking in terms of problem setup. I couldn't start the problem by flipping this to 3/2, because when I do that, I would have to do the entire side by 3/2, and then I would have 2 terms inside my radical. And we can remember from previous work, taking the square root of multiple terms at the same time is very challenging. Probably beyond any math that I would expect you to do at a high school level course. So when we're looking at this, we're looking to say, get rid of this so that the only thing left on this side of the equation is the monomial that has that exponent on it. Just like it was here, a single thing raised to a power, I was able to take care of it. When I had a single thing being raised to a power, I was able to take care of it. Get this by itself first, and then worry about trying to get rid of the exponents. All right, I hope that's helpful, and good luck with your work.